Now, we had been working with one line. Now we're going to work with two lines, solving a system of equations using elimination. When we say system of equations, what we mean is we're working with more than one equation and they're interacting with each other. Our objective will be to eliminate either the x or the y, then work with the variable that was left. So even though we have two variables, we're going to get rid of one temporarily to work with the other one, and then we come back to the one we eliminated. A preparation step to solve a system of equations is to make sure that the x and the y are on the same side of the equal sign. Align the x's with the x's and the y's with the y's. Here's a system of equations. Notice we have x, y, x, y. And then this 12 is over here, and it should be with the other side with the numbers. We should only have the x and the y on the same side of the equal sign, but nothing else. So we have x, y equal a constant. Notice that these are not aligned. This x should be in the column of the x's, and this y term should be with the column of the y's. And this constant should be on the other side. Simplify equation 1 by canceling the fraction. Look, it's easier to work if these are not fractions. So what you could do is multiply the whole equation by a 12. 12 times the first term, 12 times the second term, 12 times the term on the other side of the equal sign. So it's 12 times this term, 12 times this term, 12 times this term. And this is what you get. Simplify. So once you simplify, you do the multiplications wherever you can. These are the equations, what they look like. Notice that now you collect like terms. You go column by column, combining. If you combine these two, you get a 0. If you combine these two, you get a 0. And if you combine these two, you get a 0. 0 equals 0. When you get a true statement and you're solving a system, you get a true statement, then you know that's an infinite number of solutions. Here's another system. So we have a system of equations. Notice the x and the y are on the same side, and they're lined up. The x's with the x's, the y's with the y's, the constants with the constants. Since we have a fraction here, we're going to go ahead and multiply equation 2 by a number that would cancel out that 2. So even though this is the 2 we want to get rid of, you have to multiply the whole equation, both sides. Otherwise, we're changing the problem. So 2 times the first term, 2 times the second term, 2 times the term on the other side of the equal sign. This is what we get. So we use this one instead. That was the second equation, right? So this one's going to replace the second equation. Notice the first equation is just waiting to participate. Now, we would like to eliminate one of the variables, either the x's or the y's. So we're going to multiply the second equation by a -2 because after the multiplication, we have a -2 here. Even though we had to multiply the whole equation by the -2, we wanted it right here, especially because now when we combine these terms, they are eliminated. And now, if they're eliminated, you just combine these two. This is 4 minus 3 is 1, right? 1y. 5 minus 4, 1. So y equals 1. Let me put it for you so you can see what happens. So y equals 1. That's why we're saying over here that y equals 1. We figured out what the y is. It's a 1. Now that you found one of the variables, you use that to find the one that's missing. Now choose any equation you like to substitute the y. So you can choose this one, this one, this one, and this one, wherever there's a 1. I'm going to go ahead and choose this first one. I'm going to put the result of the y in here. So that gives me 2x minus 3y equals 5. Notice now we just have to worry about the x. So get the x by itself, start moving things away from it to the other side of the equal sign. So this is what we're left with once we move it to the other side of the equal sign and we combine like terms. Then finally come back for the 2, divide both sides by the 2, and x turns out to be a 4. So now we have the exons. So we have the y and the x. So the solution is 4 comma y. You always put the x and then the y. A solution is a point of intersection. If you would have drawn those two lines, they would have intersected in this. So a solution of a system means point of intersection. Now visually, right here we have three ways the system of equations can turn out to be. Either the lines are going to intersect at one point, like the previous one. They're not going to intersect, that's what we say. Or they intersect everywhere. Then we say number of solutions. It's like the line intersecting number of